Students, today we shall see that multi-level feedback queue. This was designed and it was so important that Turing Award was given on this topic, which is considered to be a Nobel Prize in computer science. Let us see what was that. Now, our aim is to reduce the waiting time. Suppose jobs are like this. Arrival time and the ready time are considered to be the same time. How much service the job requires. And then interval during which the job was served. Here was job A, which has arrived at time t equal to 0 and it requires a service of 30. During which interval it should be served. Suppose later on this job comes at time t equal to 8. It requires a service of only 4 units. No, just 1 minute. Not this. Paper will be given to you at 12:30. So, sir.
Okay, sir.
It is not being given. We shall give you at 12:30. And I am writing down the instructions for it. At 12:30, I will give you the paper. Is it correct? Don't
Okay,
bother.
sir. So I thought that it was okay.
No. Fine. So you see how to serve it. We can serve it from 0 to 30. And then we can serve it using 30 to 34. Now, the problem with this is waiting involved. Waiting involved is, it was having no waiting, but it has to wait from time t equal to 8 to 30, it has to supposed to wait, and it has waited for 30 units of the time. How to reduce the amount of waiting? Keeping this objective in mind, the planning was done. The next planning was, correct. The next planning was how to reduce the waiting. The best method to reduce the waiting is what is this? If a certain job comes, it should be done first. So let us see what method is employed for it. Interval in SRTM. It will be served from 0 to 8. At time t equal to 8, what is remaining service time of job A? This is equal to 30 minus 8 equal to 22. What is service time of new job which has arrived? It is 8. 8 is strictly lesser than or equal to, strictly lesser than 22. If it would have been greater than or equal to 22, then we would permit A to continue. So in that case, what we do, at 8, we shall preempt it. Oh, service time, yes, service time of this is 4. 4 is fully correct. Good thing. You should correct the mistakes. 4 is less than 22. So we shall continue it with, we shall not continue with A, we shall preempt it and we'll do from 8 to 12. And from 8 to 12, 12 to 34, we shall complete it. How much was the waiting involved in this? Waiting involved in this was 0. And what was the waiting involved in this? It was waiting from From 8 to 12, it was waiting. So which is 4 unit time it was waiting. So in this way, we can reduce the waiting time. But the problem is, yes, that is correct. For A, it is 4 and for B, it is 0. But the main problem is that service time of the jobs is not known in advance. In my time, when we give our execute command to a program, at that time we also specify how much time that program is supposed to take in execution. Is it correct? And if the program doesn't finish within that time within execution, the program is removed with incomplete output. But later it was found that how I can find out how much time the program will take in execution. Is it correct? A user cannot find in advance. Service time is not known at the arrival time of the job. So, what method is employed? Every job is given a time quantum of 10. And if it doesn't finish within that time, and if there is another job waiting, then that job is permitted, which was called a circular, rotational, round robin. But later on, it was found that round robin is also not a very good method. Hence, we went, because in the round robin, there was a queue. There was a queue of the processes, and every process in the queue in turn was given 10 unit time. And if it is not over within 10 unit time, it was put at the back of the queue. And in this way, rotation was going on. But later on, it was found that one queue is not sufficient. We should have 2 queues. We shall see later on what are 2 queues. But at present, let us see what is round robin. Now, job A arrived. In the beginning, we talked about without preemption. Then we talked about with preemption, and with preemption we are continuing, which is round robin. Job A will be given 10 units of the time for service. It is not over. So at t equal to 8, what is Q? In the queue, job B is there. At t equal to 10, job A is removed, preempted. Execution of the job A is stopped, and job B executes from 10 to 14. And job A in the queue, job A starts, is put. So this is what it happens. Okay. Afterwards, from 14 to 24, job A is supposed to execute, but we see that there is no other job. So in place of 24, it will continue till it finishes. So this was the method of round robin. Later on, at t equal to 10, A enters the queue. You are fully correct, and B starts execution. You are fully correct. No. What is waiting time of job A? Job A was waiting from 10 to 14. So it was waiting for 4 unit time, and job B was waiting from 8 to 10. 8 to 10, it was waiting for 2 unit time. Is it correct? And we have seen this queue. Okay, fine. Now, here, two problems arise. One queue was not found to be sufficient. And another problem was the problem of critical section. We shall see both these problems one after the other. What was the problem of critical section? We shall see to it. Let us see this. Job arrival and service. Suppose there is a job P and there is a job Q. Job A has arrived at time t equal to 0 and Q has arrived at time t equal to 8. Now, what kind of service it requires? It requires 12 unit. After serving for 12 units, it needs an execution time of 16 unit critical section. And afterwards, it needs 13 units of the time. So total service required by the job P is how much? 12 plus 16 is 28 plus 13 is 41. So 41 unit of the service job P is requiring. Initially, 12 units of the service and afterwards 16 units of the critical. What is the definition of critical? When one job is executing its critical, another job cannot execute. What about job Q? It requires 7 units. And it requires 24 critical. And afterwards, it requires 13 unit of more time. It needs it. We shall see how the service of this will take place. Job A will be given 10 unit time to serve. So job A will be executing from 0 to 10. And what about job B? Job B will be executing from 10 to 20. This is how the job A and job B will be given 10 units of the time. Fine. Afterwards, job P will be executing from 20 onwards. But you see, job Q was served for 7 unit time normal, and afterwards 3 unit of the critical work it is doing. So When a job is in its critical section, another job cannot be in critical section. So job P will be preempted after 2 units time. Why? Because job P cannot execute its critical section if job Q was in its critical section. So it is preempted and job Q is permitted to complete its critical section and 22 to 43 it is supposed to complete. Is this all right to you? And afterwards job P, good Dipankar, it is good, proceed. Afterwards this job from 43 it is given 10 units time. And then this job is given again further 10 units time. It is given further 10 units time. And this job is given further 10 units time. Now it is out of critical also. And how much was the remaining time for this? Why not? Why P should not take it at all, Kasif? Kasif? First of all, we were even not knowing that critical section will start. We have no knowledge. What type of service a job requires in the beginning? When the critical section starts, we come to know that the critical section has started. Kasif,
So,
is it
sir,
clear to you? Why
no,
even 2 units is taken? We should not take it at all. No. We will
so,
take it. We were not. Why it should not? It is turn. It is a turn of P. So we shall give it the time. Is it correct? Yes.
so, sir, why 2 is only taken? It might happen that in 1 unit of time at 21, it would know that critical section was going on in queue.
No. Critical section. Yes. Correct. Critical at time t equal to 20 itself, every person was knowing that critical section is going into queue. But critical section of the queue does not prevent any other job to execute. It only prevents any other job to execute in its critical section. Is this all right to you? That is correct as Nilanjan has written. Critical with non-critical is permitted. What is the problem now?
Sir, why only 20, at 22 it is found that
Because after serving 12 units of the time without critical section, in job P, critical section is going to start. And when we preempted job Q, it was in its critical section. Critical section of the job Q, we have left the job Q in its critical section. Then any other job of non-critical section can be done. Is this correct?
okay, sir, clear.
Clear? Yes. And we do not want to prevent any job unnecessarily. This was true in deadlock method also. A job will not be denied any resource if it is available. You see, Anirudh, you are fully correct. Limit is only 10. If there would have been one more job R afterwards, then from 20 to 32 we would have done it and we would have given chance to job R. But there is no other competitor for at 32. At 32 only thing we can do P, but P needs critical. So there is no other competitor. Is it correct? Anirudh, is it correct to you? That is correct. From T equal to 70 to 20, in its critical section Q is running. Fully correct. Any more doubt now? Now, other things we can complete. Q is will execute from 53 to 63. Now, then 43 to 53, 53 to 63, then 63 to 73. Is it correct? Then it would be executing from 673, 3 units of the time was remaining, 73 to 76. It would be finishing. Then the remaining time from 76, let us find out how much is that time. 0 to 10, 20 to 22, 43 to 53, 50, 53, 63 to 73, and 76 to 85. We have to find it out. 73 to 7, yes. 76 to 85. Let us see how much time is remaining. Here critical section came. Then we need 16 unit time. 16 to 29 time we needed. So it is 85. Is it correct? So we have to, yes. Yes, we can find out how much is the waiting. How much is the waiting? Let us see. Let us find out what is waiting time of A. One method is this, that let us see when A waited. Find out when A waited. There is a formula for waiting time. We can use normal method also. Waiting time is equal to finish time minus arrival time minus service time. This is a formula. Let us see for A how much it is. Finish time is 85. It has arrival at time t equal to 0. And it was requiring the service of 12 plus 16 plus 30. So 12 plus 6, 28, 41. And 41, it has given you 44. And what about B? B finished at 76. Minus it arrived at 8. And it was requiring a service of 7 plus 24 plus 13. This is equal to how much? Let us see. 31, 44. This will be 68 minus 44. It is 24. Suppose you are writing 22 for B. Why? That is correct. Let us see this. When was P waiting? P was waiting from 10 to 20. Then 22 to 43. And 22 to 43. Then 53 to 63. And 73 to 76. So this is 10 plus 21, 31, 41 plus 44. So total is 44. And when was Q waiting? Q was waiting from 8 to 10. Then 20 to 22. 43 to 53. 63 to 73. So 2 plus 2, 4, and 10, it is 24. Okay, fine. Now, we further proceed. What is the problem of normal round robin? Why the multi-level feedback queues came? We shall be talking about this. Let us see this. Arrival time and ready time are the same. They are used interchangeably. And we shall talk about round robin. Then we shall talk about multi-level feedback queue. The difference between these two we shall be seeing. Okay. Job P, Q, R, and S. It is ready at time t equal to 0. It is ready at the time t equal to 5, 7, and 22. Their ready times are like this. Now, each of them is requiring a service of 30 units. 30, 30, 30, and 30. What will be done in round robin? Job P will be solved from 0 to 10. Now let us see what is a queue. Here was a queue. At t equal to 5, time t equal to 5, queue start. Let me use the job names as Q came to Q. Now, at t equal to 5, time t equal to 5, that is correct. At time t equal to 7, Q and R are in the queue. And time t equal to 10, Q service for Q will start from 10 to 20. And in the queue, what will remain? In the queue, R will be there in the beginning and P will be afterwards. That is correct. R and P is in the queue. Good. Now, so at time t equal to 20 to 30, R will be served. So what will happen at time t equal to 20? R will be taken out. P will be in the queue left out only. Now, we shall see that at time t equal to 22, S will be coming to Q. And P is already there in the queue. So S is after P. Can you see this? And we shall see the difference in multi-level feedback queue that this is not permitted. So, yes, that is correct. I have made some mistake. At time t equal to 10, R and P are in the queue. And R is taken out and Q is put at the back. Yes. Q has been put at the back. So here also Q comes. So it will be coming in this manner. Fine. Now, you try to complete it. Is it correct? You try to complete it. Meanwhile, I am sending the question papers to the students of mostly non-mathematics, non-18 MA students and non-MTech students. Mostly they are non-mathematics. Is it correct? Mostly, not all. Non-18 MA, I am sending it, and these students whose name are written, they should tell whether they have got the question paper or not. Okay, and you should send the answer by reply mail only. No other address you should send. Send answer by reply. Write roll number in the subject. I am sending the question paper. Yes, I have sent the question paper. Juman, have you got the question paper, Juman? Write it, got it or not got it, Juman? I have sent the question paper.
Yes, I got it.
No, please write your name. You write got it and Juman. Amit got it. Suman Kumar got it. Suman Kumar, got or not got? Amit got it. Yaswant got it. Suman got it. Fine, 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 fine. Now you do with these questions and other students will be attending the classes. Fine. Any person who has not got it, forget about got it. Yes. Any person who has not got it, type your name. That is correct. Not for all people. If any person has not got it, then only then you type your name. Is it correct? Yes. Now, now at time t equal to 22, S joins the queue. So what will happen? 20 to 30, R will be served. And at time t equal to 30, Q, S and R will be in the queue. So from 30 onwards, P will be served. 30 to 40, P will be served. That is correct. 22, it is PQS. 40, it is SRP. 30, it is QSR. Then it is SRP. In this way, it will proceed. Got it. Yes. Fine. In this way, it will proceed. Let us reduce their service times. Now, so PS will not be served from 30 to 40. Rather, 30 to 40, P will be served. Is it correct? Then Q is in the queue. So 40 to 50, Q will be served. Then from 40, 50 to 60, this will be served. And 60 to 70, this will be served. And if their service time was more, then 70 to 80 P would have been served. If the service time of P would have been remaining, then P would have been served. But here it will be, this will be served. Is this all right to you? Any doubt? Any doubt? Any question? Sekhar Batch, your doubt is clear? Now, we shall see that there are two queues in multi-level feedback queue. High priority queue and the low priority queue. This is high queue and low queue. You see, 70 to 80 P will not be served because nothing is remaining in it. Service time I changed from 30 to 20 because. Any doubt now? Yes. Now high priority queue and low priority queue. In multi-level feedback queue, 0 to 10, A will be served. At time t equal to 5, Q will be put in the high priority queue. And at time t equal to 7, R will be also be put. You see 70, there is service time or service of P is over. Jannat, service of P is over. Nothing is remaining. I changed from 30 to 20. Is it correct? Yes. Yes, now. Yeah, done now. At time t equal to 0 to 10, P will be served. Afterwards, what will happen? At time t equal to 10, P will be preempted and will be put in the low priority queue. When a job enters, it is put in a high priority queue. When a job is preempted, it is put in the low priority queue. Is this correct? So this is the method which is getting employed. So at time t equal to 10, job P will be put into low priority queue. Then what is going to happen? From 10 to 20, Q will be served. So at time t equal to 10, only R is in this. And at time t equal to 20, P and Q are in the low priority queue. So time t equal to 20, nothing is there in this queue. Empty. Nothing is there in a high priority queue. So from 10 to 20, this will be served. Then from 20 to 30, R will be served. At time t equal to 20, this is 20, that is correct. Now at time t equal to 22, job S has come. It will enter in the high priority queue.
Hello?
That is correct. You are correct, Pranav. We are doing this so that new processes can start early. Because if a job has not finished within the time quantum, it is expected that it is a long job. And a new process may be very small. What are you saying?
Sir, I am giving the test and I have sent a mail without completing the whole question.
By chance, you send it again. You
Okay,
complete it and send it again. No problem.
Okay, sir. Okay. Thank you, sir.
Yes. You can always send it. Okay. Now, in 20, PQ will be put. Now, at 22, S will be put in the high priority queue. So, up at 30, what is going to happen? At 30, P, Q, R are in the low priority queue. And at time t equal to 30, at time t equal to 30, the service of S will start from 30 to 40. You see, there are two queues. When nothing is there in a high priority queue, only then we move to the low priority queue. Is it correct? So this is multi-level feedback queue. What is feedback? A job goes to low priority queue if it is could not complete within the time given to us. Time given to it. If it could not finish, it is given in that priority. Is it correct? Yes. What else do you want? Any doubt? Why new processes are given priority, Pranav? The reason is most of the new processes will be smaller in size. That it will be put in the low priority queue. Kasif, if service time is more than the time quantum of R, it will be put in the low priority queue. Is it correct? Yes. Yes, that is correct. Sekhar, we shall be talking about this little later. Is it correct? Why it is not moved to low priority queue as 20 to 22 is high priority queue is nil? I have not understood, Sekhar, what are you telling? Multi-level feedback queue, ML, multi-level feedback queue. It is multi-level feedback queue. It is multi-level feedback queue. Any doubt? Yes, new jobs are put in high priority queue. Yes. Any doubt? Yes. Problem in RR was that there may be few jobs whose time taken is very less. They will be coming at the back of the queue. The reason is this: long old jobs are circulating. Do you understand? This was the problem with RR. There may be a job which has just now come, which only requires a very small amount of service. You see, time t equal to 20 to 22, high priority queue is empty, but the execution of the job R is going on. Is it correct? Then why to come to low priority? Some other new job can be put in high priority, Sekhar. No. If more new jobs come, then again the low high priority job will be filled again. You see, shortest job next is best. I can understand it, Sivendra, but we don't know the service time of the jobs in advance. Do you understand it? Service time of the jobs are not known in advance. Yes, that is correct. When high priority queue is empty and along with the execution of no other job is going, then we move to the low priority queue. Yes, you are fully correct. Fully correct, Sekhar. Any doubt? Why we are using multi-level feedback queue? PQR are already lot of time taking jobs. They are rotating in a queue with time quantum 10, 10, 10. If a new job comes, which only requires very small amount of service, why it should wait in rotation? Because of this. That is why two-level queue was there. Okay. Now, at 30 PQR is there. At 20 S has come. So what will happen? S will be served from 30 to 40. And from 40, now S will be served. Now this queue becomes empty. At time t equal to 3, nothing is there into this. And at time t equal to 40, P will get a chance to serve. So P will be served from 40 to 50. Is it correct? And 40, it will be QRS. Is the method clear to you? Any doubt? Ask question. Multi-level feedback queue is more than that. That is something else. Very big. Harshvardhan, it was a very good question. How the time quantum should be decided? Is it correct? So the time quantum will also be varying. Is it correct? In high priority queue, time quantum will be less, and in low priority queue, time quantum will be more. Is it correct? Yes. That will also be in the case. Is this correct? Yes. When a job comes on and given the high priority, it is assumed it is a shorter job. So a time quantum given to it will be less. And if a job is in low priority queue, it means that already it has taken a lot of time of execution. In future, it will also take more time in execution. So what will happen? Give more time just now also. Is it correct? Yes. Is this method clear to you? That is correct. If the time quantum is, so we have the multi-level feedback queue also has a solution for it. There is a solution. Yes, it also tries to find out the solution for it. Is it correct? Yes. Yes. Because if the time quantum is very less, then unnecessary switching, how to stop unnecessary switching, we shall be coming to the next. No, there is no problem. How do we know it is 11 unit time? Is it correct? How do we know it is 11 unit time? That, okay. After finishing 10, it is not known that will take only 11 unit time. So this type of problems are always there. Is it correct? You see, when I was a student, when we used to give a printout for printing there was only one printer in the whole IIT. We give a command for printing. We have to write down how many pages for printing it will be taking. Suppose it doesn't finish within those many pages, then it will write last line of last page limit exceeds. But how do we know that there was only one more line remaining? Maybe that in the last line, rather than writing page limit exceed, it could have written the remaining line, only one line was remaining to be printed. But such problem is always there. Is it correct? Which we cannot get rid of this. Certainly, waiting time is less in multi-level feedback queue. It is certainly less. Okay, fine. So it will be 40 to 50 and 50 to 60 and 60 to 70 and 70 to 80. We have already done this. Now we further proceed. In high priority queue, a job is given only 3 unit time quantum. In high priority queue, time quantum is 3. In low priority queue, time quantum is 10. Okay. This is how we proceed. It is I don't know what is the question you are asking. Is it correct? It is an extension of the past topic. After round robin, there is a multi-level feedback queue, and the person who designed it was given Turing Award. And you should be knowing by this time that Turing Award in computer science is considered to be a Nobel Prize in computer science. Is it correct? Yes. Now, let us see. No. The last 2 lines are the new example. No, it is a new example. Last 2 lines are the new example. New example starts from here. Okay. Yes, I am increasing it. Now, let us see. Means different time quantum. Different quantum. Job A is given a time from 0 to 5. Is it correct? We have to see. We have to see. Is it correct? I don't think it will be the case. No, you send me a mail and I will talk to you, Sri Krishna. I don't think. Sometimes it can be more. Is it correct? The reason being that the new job which has, yes, it may be more also. No, you are correct, Sri Krishna. It may be more because we are giving a high priority to a new job, keeping in mind that it will be smaller in size. But if it does not turn out to be smaller in size, it turns out to be longer in size, then it means that we have given the wrong choice to it. So waiting time will increase. So you may be correct. Is it correct? You may be, and you see that time everything was equal size, so the problem has come. Job P will be given 3 unit time. But at time t equal to 3, nothing is there. So let us see. High priority. And there is a low priority. Is it correct? Now, P will be given only 3 unit time, but what are you writing? Why P is going from 0 to 13? P will be going from 0 to 5. P will be giving from 0 to 3. But at time t equal to 3, nothing was there. Is it correct? So we permitted it up to 5. At 5, a job with P was moved to a low priority queue. Gyan, why you have written 13? I cannot understand. Then Q will be given time 5 to 8. Is it correct? And at 7, another job R has come, but 3 unit time will be given to a high priority queue. Yeah, at time t equal to 3, P has become a low priority, but there is no competitor for it, so let it go through. That's yes, fully correct, Jannat. You see, let us assume 10 unit time for low priority. But you see at time t equal to 5, another job comes now. Now, preemption within time quantum can also take place. Once a job in high priority queue comes, then a low priority queue job may be removed even when its time quantum is not over. When a job of high priority comes, then a running job of low priority may be removed even then time quantum not complete. Even when time quantum is not complete. Yes, that is correct. Vikas has written fully correct. So P was running in low priority, but its time quantum was not complete. So it was removed and Q was running. Now at 7 R came, but time Q was a high priority from 5 to 8. So at 8 it will be removed and R will be executing from 8 to 11. Is it correct? Yes. Do you understand? Now at time t equal to 5, T was moved to low priority, and at time t equal to 8, Q was also moved to low priority. Is this thing clear to you? Oh, no, only one scheduling algorithm. How there can be two scheduling algorithms? Only one scheduling algorithm. Is it correct? Is it all right? Yes. Now, at time t equal to 11, you are fully correct that it R was high priority queue. It should be moved to low priority queue. But as one person has suggested that we don't want to remove unnecessary switching, so we continue up to 18 with this. Is it correct? Class over. Any discussion can be done. Is it correct? Class is over. Any discussion of any type can be done. Gyan, you see, technically speaking, to reduce unnecessary switching. Why up to 18, Gyan? Why up to 18? Why R is running up to 18? To reduce unnecessary context switching. At time t equal to 11, R had moved to low priority. And no high priority job is available. So what is going to happen? We could have given chance to P and Q. But P was also low priority, Q was also low priority, and R was also low priority. Technically speaking, R is after P, Q. But to reduce context switching, to R was moved to low priority queue at time t equal to 11. You are fully correct. But to reduce context switching, let R continue because no high priority job is there. Yes. You see, at time t equal to 5, Q was in high priority. So that is why it was getting executed from 5 to 8. And at time t equal to 7, high priority Q was containing only R. What else is your doubt? Any doubt now? Any doubt? No. No, Kasif. No. Then the rotation will start, na? In the low priority, it has completed 10 units. It in low priority, it has completed 10 units. So the time should be given to P. So P will be executing from 18 onwards. Maximum time is 10, yes. Yes. Once the discussion on this is over, we shall discuss look. After this discussion, we can ask now also. Yes. Suppose another now. Suppose S would have come at time t equal to 15. Then it will be 8 to 15 and 15 to 18. No, I will not complete it in the next class. Because we can continue on this for one semester. Multi-level feedback queue is a very long topic. And lot of things can be discussed into this. So let us finish off. And we can answer the question by mail. Is it correct? Yes. That is correct. So at time t equal to 18, P will be starting. So Q and R will be in the queue. So P will be going from 18 to 22. Now S has come at time t equal to 22. It will be continuing from 22 to 32. What is your doubt? That is correct. When R is over 18, it again goes to low priority queue. What is your doubt? Any doubt now? I am giving it. I am giving it in chart. Let some discussion be over. Okay, I will explain it. I will explain it. Is it correct? Yes. Let me put it into chart. This first. Yes, S is 2232. Yes. I am explaining this.